Okay, so you guys have these straight. First period was getting a little bit confused on a couple of these, but hopefully they've got that straight now. You've got your reciprocals now. Now we are going to talk about a different pairing with the trig functions. It's a different relationship, and it's called cofunctions, okay? The expression that I'm gonna mention to you guys repeatedly to help you remember how we handle cofunctions is I'm just gonna say cofunctions are complementary. And it's easy to remember that because it's cofunctions are again, right? So complementary. That's what all of this fancy algebra is telling us, and I'm going to explain what it means. But here's the pairing of the trig functions. It's different from the reciprocals. It's kind of more in tune with what you probably thought of to begin with when we were talking about our trig functions. So the easy way to remember this, in my opinion, is that each of the trig functions plus the trig function that has the co in front of it, right? So it's sine and cosine, it's secant and cosecant, and it's tangent and cotangent. So those are the co-functions. So in my opinion, these are a little bit easier to remember just because they kind of sound like they should go together, right? Sine and cosine should go together. Secant and cosecant, and tangent and cotangent. So keep in mind too, notice tangent and cotangent, they are reciprocals of each other. They are also co-functions, okay? All right, here's why this works. So do me a favor, grab your calculators. We're going to get to those here in just a minute, but I'm going to draw a triangle here, triangle ABC, right? So we know in any right triangle, angle A and B, if they are the other angles besides the right angle, that those have to add to 90 so that we have a full 180 degrees for our triangle, right? So, all right, let me just make this up here. Let's do a star, an @ sign, and check mark. Okay. You'll need your calculators in just a second, but I just want to look at the ratios. If I ask you to tell me the ratio for the sine of A, of angle A, what do we know the ratio would be for the sine of angle A? Lucy, what would be the sine for angle A?
It would be the @ sign over check mark.
Okay, so @ over check mark sounds good. For the sine of A, what about the cosine of A? Alex Subin? Think about your SOHCAHTOA if you need to. Okay, good. There you go. So cosine of A would be star over check mark. So that's in relation to angle A. Now, though, if we, oops, that's not going to want to erase. Now, if we look in relation to, let me change colors here. If we, let me do this. If we look in relation to angle B, all right, Ireland. If we look in relation to angle B, so if I ask you for the sine of B and the cosine of B and what those ratios are. Taya, what's the ratio for the sine of B? Star over check mark. And then the cosine of B, Owen?
Star over check.
Careful, cosine, so adjacent over hypotenuse. Okay, so @ over check mark. Guys, what do you notice with these particular ratios that we just came up with? Yeah, they're kind of like they're opposites here, right? The sine of A is equivalent to and is equal to the same thing as the cosine of B. And then the cosine of A is equal or equivalent to what we know the sine of B is equal to. And it's that relationship because those are the angles that add to 90 degrees. It could create that right triangle, okay? So I think for some people it kind of helps to see this visual of that. But that's exactly what this is saying, right? If we think about what our co-functions are, those sines and cosines are co-functions of each other. Basically thinking about things from the other perspective, we're going to get that same ratio, okay? So that, I think for some people that kind of helps. Others, it's kind of like, yeah, right, whatever, just move on. I purposefully, once again, if you notice, I don't have any directions here because the directions sometimes say something a little bit different, but typically the directions for like this first set of examples would say something to the effect of write an equivalent expression using co-functions. So we want to come up with something that's equal to or equivalent to this cosine of 63 degrees. So we're going to use co-functions. So the co-function for cosine we know is sine, and we know that co-functions are complementary. What does that mean about the angle measures? If this is 63 degrees, what is this, bless you, what does that angle have to be?
27.
Yeah, we're going to subtract. We're going to do 90 minus 63, and we get 27 degrees. There you go. So guys, this is why I asked you to grab calculator. Plug those in. I want you to see and verify in your head. I want you to notice this on the calculator too. If you plug in cosine of 63 degrees, see what that's equal to, and then plug in the sine of 27 degrees. You should see that you get the exact same answer, right? Who in here has a CAS? CJ, it looks like you've got a CAS. Your calculator?
Oh.
Yes. When you plug in cosine 63, what does it tell you?
Cosine 63.
Uh-huh.
Sine 27.
It's telling you that sine 27. It's not even telling, which is a little bit of a problem because you need to know what the decimal value is, right? But the CAS does that where it actually tells you what that equivalent function is, right? But for the rest of you, if you've plugged in cosine 63, you get some long decimal for that answer. And then you plug in sine 27 and you get that same long answer, right? Okay. All right, secant 18 degrees. What's the co-function for secant? Someone call that out. Cosecant, good. So we get cosecant. And then we want to do 90 minus 18 degrees. What does that give us? 72 degrees. Awesome. All right. Similarly, co-function for tangent, Lucy, is what?
Cotangent.
Cotangent, good. And then we do 90 minus 52,
38.
and we get 38 degrees. And last one, the co-function for sine, Dina.
Secant. Cosecant.
Careful. For the co-function for sine, we need the co then.
Wait, what?
The co-function for sine is
Oh,
cosine. There you go. So cosine, and then we do 90 minus 81, and we get 9 degrees. Okay, that's our top set. Another type of problem you will see that has to do with co-functions as well is something like these next two problems where it says find the value of theta that satisfies this equation. In some instances, it might ask you to find the angle measures also, so we'll have to kind of be conscious of that. What you have to notice is that in each of these sets of equations that we have, we've got co-functions there, right? We've got cosine and sine, so we know those are co-functions. And so what do we know about co-functions? Well, we know co-functions are complementary. In other words, these angles right here, this angle plus this angle has to be equal to how much? 90 degrees. So we're going to say theta minus 8 plus 4 theta plus 3, that has to be equal to 90 degrees. And we're going to solve. Some people get confused with seeing that theta in there. And if that's the case for you, then switch that and make it an X to make it a little bit easier to see what's going on, okay? All right, so 5 theta is equal to 95, or theta is equal to 19. Okay, so you might be asked just to find theta. That's fine. But you might also be asked, okay, no, go back in and figure out what the angle measures are and write that equivalent expression. So in other words, that means we would write, okay, cosine of 19 minus 8, that means we have cosine of 11 degrees equals sine of 19 times 4 and add 3. It better be 79 degrees if we check that, right? So just be conscious of what the directions are asking you to do. Okay, on this one, similarly, if you notice secant, cosecant, those are cofunctions, right? So that means that these two angle measures have to add to 90 degrees. And so we're going to solve again. So 7 beta plus 6 equals 90. So 7 beta equals 84, or beta is 12. So that's if you're just finding beta, the angle measure. 12 times 5, 60. So secant of 74 degrees is equal to the cosecant of 24 minus 8 is 16 degrees. Do these add to 90? Yes. So that's a nice way to check, right? Okay, try those 6 down there for yourself. We'll go over those answers in just a second, okay? All right. Pretty straightforward, right? Not too bad? Okay. Do me a favor, turn your page, fold your papers, fold the packet so that you cannot see. At the top of page 23, fold that packet, don't peek. You need to see if you can get these memorized. Write down what the pairings are, make sure, okay? So practice that without peeking. Write the pairings, which two go together, which ones are cofunctions. We're just gonna look, let's do 2 of these down here. We'll save these for some extra practice if we need it. And I'm not sure that we do right now, because you're gonna have worksheet to do in just a couple of minutes. Let's just try those for yourselves. Find theta, but then also go back and plug in and find the corresponding expression with theta plugged in, okay?